Bismillahirrahmanirrahim. Today we will discuss our experiment number 3, which is step turning operation on CNC lathe machine using CNC simulator software. Our layout will be the same. First we will discuss what step turning is, then we will design code for the step turning process. Most of the G and M code commands will be same as used in the previous lecture, so they will be repeating. At the end of the code, at the end of the experiment, we will check our code for any error on simulator software, like we did in the previous lecture. If the code will be okay, then we can use this code on CNC lathe machine. Now the first thing we will discuss is what is a step turning. Step turning is the operation in which material is removed from the workpiece to obtain various steps of different diameter. Here you can see this is our workpiece, and for each step there is different diameter. For this experiment we will use diameter of 40, 20, I think 18 and 12 mm. So there are different steps of different diameters. For this purpose, the operation used is known as step turning. Also, like in plane turning, the tool has moved in the parallel direction to the workpiece. Here, same, we will give the feed motion to the tool in the parallel direction to the workpiece. Now here you can see this is our raw material and this is our required finished job. The original diameter of the raw material is 40 mm and its length is 100 mm. And here you can see we have reduced the diameter in different steps. The first step is of 12 mm, the diameter is 12 mm up to length of 20 mm. And the next is the diameter is 20 mm up to length of 30 mm. This is 30 mm length and this dia is 20 mm. And the next one is the dia is 28 mm. This step is of 28 mm diameter and the length is 20 mm. And the next, the final part is 40 mm, which was our original diameter. So we are going to perform the experiment in which we will reduce the diameter in different steps. Now we will generate a code for CNC simulation software for this step turning. This is the first step for generating code. As we have discussed in the previous lectures in detail, it has three options: open project, new project and save project. Open project is to continue the project from the previous session. Save project is for saving the progress, as we always do in our last step. And new project, this one is for generating new profile or for the generation of new code. So you will click on the new project for generating new code. After starting the new project, you will set now the workpiece parameters. For this you will click this icon here, second right top side. This window will appear. Now this is the workpiece length. This is the initial length of our raw material, which I have set 100 mm. This is the workpiece diameter, which is the initial diameter of our raw material, which is in this case 40 mm. This is the clamp length. Clamp length is the length inside this chuck. Here you can say the length of the raw material inside this chuck is known as the clamp length, which I have set 20 mm for good clamping. We have set all the initial parameters of our raw material: 100 mm length, 40 mm diameter. All these are the initial parameters of our raw material before facing operation. After setting the workpiece parameters, now you have to select the tool parameters. For this, you will click this third icon in the figure. This is for the tool selection. When you click this icon, this window will appear. Here you can see you have different options for tools. For turning, facing, there are different tools. Now in this case, we will select this 5 number tool, which is for general turning and facing. For selecting the tool, you have to drag the tool like in this way. From here you drag the tool this like and put it there. By doing this, you have selected now the 5 number tool, which is for general turning and facing. We have no need to change these parameters of the tool. You can see that there are options for selecting other tools like 2, 3, 4, 5. These are used for selecting multiple tools. Like you have studied that in tool pose, multiple tools can be adjusted at one time. So this option is used for selecting multiple tool selection. Now before starting the coding, I will summarize up till now what we have done. First, we have opened the CNC simulator. Then we have opened the new project. Then from here we have set the workpiece parameters. this option. Then from here we have selected the tool. I think I missed this highlighting option in the previous slide. So this is the third option for selecting the tool. Now the fourth option, this is used for the coding. You have to, when you will click this icon, a new window will appear like this. I have written the code, but when you will click this icon, there will appear a new blank window. Okay, then you have to write the code for the facing operation, or what operation you have to do. I have explained this coding in the later slides, but here I will tell you for every code there are three parts: the first part, the middle part, and the end part. This is the first part of the program, like the from here this line to this line. This is the first part. This is the middle part from this line to the this line, and this is the end part from this line to this line. The first part of the program is generally used for switching options, like which units you are going to use, metric or inches, similarly to switch on the coolant. While the middle part is related with the workpiece details. You will define workpiece here, like its length, diameter, which option you have to perform. All these details will be written here. In the end part, you will now close the program, and other things like if the coolant is on, you will write the command here for switching off the coolant. Similarly, M30 is used like this line, it is used to close the program. For writing the program, you can use your own keyboard, and also the simulator on option for writing can be used, which I have discussed in detail in the coming slides. This is the keyboard of CNC simulator software I was talking about in the previous slide. This is the icon in the bottom taskbar. By clicking this icon in the bottom taskbar of the CNC simulator software, where the writing code option is, this keyboard will appear. As you can see, this keyboard covers almost all the required alphabets, and all numbers are present in the keyboard. Also, other necessary buttons like enter, delete, and backspace is also present. Here, brackets are also present. So you can see you can use this virtual keyboard of CNC simulator, or if you don't want to use this, you can use your own laptop or a computer keyboard. It's up to you which keyboard you want to use for your own comfort. This is the complete code I have written for the step running operation. You can see many commands are still repeating here, like G00, 0001, G28. These are the commands used in the previous lecture too. So I am skipping them. The new command is here this cycle: X36, Z70, F0.5, M08. This is the new cycle written here for the step running operation. I will explain this complete cycle in the coming slide with the help of figure. Rest is same. You see M30, M08. These commands are same like in the previous lectures. Now starting with the code explanation, I will start with the very first line, which was 0001. This line is the start with the code O, and it O 0001. While writing a program on unicontroller, first line has to be start with O letter. It will always followed by a four-digit number. The number specifies from 0001 to 9999. I mean, this is the range of the its own code. Whenever you write a program, it always have to be specified by specific number. So in the very first line, we will specify our program code by giving it a specific number. Now moving towards the next line, this is the N10, G21, G99, G40. Starting with the N10 line, whenever N code is used, it is used to define the name or title of block of G code. Or simply, it defines the line number. So N10 means N line number 10. The next is G21. G21 code is used to switch between the metric system of units. So when we have used G21 code, so every dimension written in the code will be considered in millimeters. It is used for metric units in millimeters. G99 code G99 code select the units of the feed rate. So whenever in the code you have given the feed rate, it will consider it in millimeter per revolution. So we can say that we have now set our units in millimeter and we have set our feed rate in millimeter per revolution. Every value you give in the code, the length of your dimension will be in millimeters and the feed rate will be taken automatically in millimeter per revolution with the help of G21 and G99 code. G40 code is used for tool radius compensation. There are two other codes, G41 and G42, for left and right tool radius compensation, but here with the help of G40 we are selecting automatic tool radius compensation. Now the machine will our CNC will automatically select the tool radius compensation according to the our tool and workpiece. Now discussing about G00 code. This code is used for the rapid G00 code is used for rapid positioning of tool. For example, if the tool is away from the workpiece, by using the G00 code, the tool will rapidly position towards the workpiece. This is the purpose of G00 code. G28 code. G28 code is used to move the tool to a reference point. Initially, we will set a reference point for the tool. So when we use a G28 code, after the work is finished, the tool will move to its reference point, which we have set earlier. U0 and W0, these are the secondary movements about Z and Y axis. These are used to move the tool in the X and Y axis according to our positioning. Now starting with the next command, this was T0101. Normally T command is used for changing of tool. As we have discussed earlier, there are a number of tools, almost 4 tools can be applied at different tool posts. So T command is used for changing of tool. Here the first two digits 01, it represents the tool number 1, and the second 01, this number represents the offset number. It means we have tool number 1 at one position. I am calling my tool which I have number in number 1 position to offset number 1 for the facing operation. So whenever T command is used, it is used for changing of tool. It can be 01, 02, 02, 01. Different tools at different numbers. Always remember the tool position for calling the specific tool for specific operation. Like I have installed my tool at first position in the earlier slides, so I am recalling it from the first position. The next line is G96. G96 is used to rotate the spindle at constant RPM. So here you see the next code is S500. Both commands together means now the spindle will rotate constantly with the RPM of 500 revolution per minute. The rotation unit revolution per minute was selected in the previous slides. The next is M03. M03 is used for selecting clockwise rotation. Its opposite is M04, which when applied the spindle will rotate in anti-clockwise direction. Now x42 and z2, this command is new here. For explaining the command, I have to draw the workpiece. So let me draw the workpiece. uh, let's suppose this is your workpiece and this is x-axis perpendicular to the workpiece, and this is the z-axis. So x42 and z42, these are used to give the initial points to the tool. As you remember, our diameter was 40. So let me write, our diameter was 40 and the length of our workpiece was 100 mm, and this length was 100 mm. So by x42 and z2, what will happen? Our tool will move 2 millimeter away from the workpiece in x direction and 2 meter away from the workpiece in z direction. Let's suppose this is our tool. Here, this is the point. This is the point. There will be 2 mm clearance in both axes. From z axis, it will be 2 mm away from the tool, and from x axis, it will be 2 mm away from the workpiece. Our tool will be, this is gap is 2 mm. So by giving that command of x42 and z2, our tool will move just to this point 2 mm away from the workpiece. When we start cutting, it will then cut the tool in both direction, because our workpiece will be rotating, and with the movement of tool it will be cut in both direction, in circular direction uniformly. No G90 command. This command is used for turning cycle. This cycle is used for stock removal in parallel tool part. For explaining this, let me draw the workpiece. Now suppose this is your workpiece and this is your tool. Now parallel tool path means for reducing the dia, your tool will move in this direction and along the z axis. Remember the axis I have drawn. This one was your z axis and this one was your x-axis. Now what will happen with the help of using G90 command? There are 4 options. 4 different steps are going to be performed in G90 cycle. Rapid to X position. Rapid to X position, it will give the tool movement in X direction, in this direction. In the last slide I said the X direction was perpendicular to workpiece. Basically X and Z are perpendicular to each other. I have been mistaken in the last slide. So X and Z are perpendicular to each other. Rapid to X motion, this will give the tool motion in this direction, and feed to Z position, feed will give the movement to the tool in this direction. So first our tool will move into the workpiece for cutting, and with the help of Z feed it will move in this direction. Similarly, feed to start X position, when our required cut is finished, tool will move back to the initial position, and rapid to start Z position, then it will again move into the workpiece, and this cycle continues. I will explain the cycle in the next slide. This is our turning cycle. These 4 commands are explained in the next slide too. Here's the cycle line, the 4 distant moves with one line of information. These are the 4 distant moves which are explained in the next slide too. Now explaining a turning cycle, remember this was our raw material and this is our required step turning operation. This was the original diameter of 40 mm and we have to reduce it up to steps of 28 mm, 20 mm, and this one is 12 mm, up to different lengths. So what this cycle is doing, first one is x36 z minus 70. Now remember in the previous slide we have set the x42 and z2. What it have done, it have, let's say this is 40 mm line. This is by x42 and z2 our tool was at this position, somewhat somewhere there. When you give the command of x36, it will move up to point of x36 in this direction into the workpiece up to point of x36 and z minus 70. When you give it the command of z minus 70, it will move in this direction up to minus 70 mm. So what it will do, it will it will reduce the die from 40 mm to 36 mm. This is the first cycle. Next cycle X32, from X36 it will bring it into the X32. Next is X28. In different steps, as we are repeating in the previous lectures, we cannot reduce the diameter in one go. So we use different steps. From X36 it will bring it to the diameter of X28. This one is final diameter X28. From first, from 48 it will bring it to the X36, then X36, then X32, then X28. This one is the X28, up to length of 70 mm. From this point to this point, this length is 70 mm. So now our dia is reduced from 40 mm to 28 mm. This part is 28 mm, up to length of, from this point, initial point to this point, up to length of 70 mm. Now the next one is X24. This one is X24. This part is X24 mm. So now X24 up to the length of Z50 mm. Z minus 50. Now what will happen? Our tool will move from this point and move up to this point. You can see initial was Z minus 70. Now Z minus 50. We have removed this 20 mm. Now by removing this 20 mm, 70 minus 20, this 50 mm, this is the required diameter of 28 mm up to length of, from this point to this point it is 50 mm. From initial point to this point, this is now 50 mm. Now by removing from diameter 36 mm, now this part is 28 mm. You can see this initial part is 40 mm, this one is 28 mm, and now this one is 24 mm in the first cycle. By repeating cycle, we will bring up to from 24 to 20 mm. The last final part is now 20 mm. Here you see this command. The first step, it will move from Z to minus 50 and reduces the dia from 28 mm to 24 mm. Then in the next part, from 24 mm, the dia will be reduced from 24 mm to 20 mm. This part is now 20 mm when it is finished. In the next and final part, we have to bring this part diameter up to 12 mm. So you see here command is X16 and Z minus 20. Now what will happen? From this 20 mm, the tool will move and up to 20 mm in this part, up to this length. And now what will happen? It will bring the dia from this 20 mm to 16 mm. In the first part, the dia will be reduced to 16 mm, and in the next part, the dia will be reduced to 12 mm. Here you see 12 mm. And Z, initially Z was 70, 70 minus this 20. Let me use pointer. You see initial the Z was minus 70. After moving minus 20 this to minus 20, the Z length was minus 50 mm, and after again removing this 30 mm, Z length is now minus 20 mm. So minus 20 mm and with dia of 12 mm. So you can see this was a step turning cycle. Let me summarize it again. This Z was initial Z minus 70. You can add 20 plus 30 50 plus 20 70 mm. This whole length was 70 mm. This whole length was 70 mm, and dia was from 36 to 28. And the next line, the Z was 50 mm. Z is minus 50. You can add 30 mm plus 20 mm. This is Z 50 mm. Up to diameter from 24 to 20. We have reduced this part to 20 mm, and in the next and final step, Z was minus 20. You see this only length minus 20 mm, and dia is from 16 to 12 mm. We have reduced the dia up to 12 mm. So at the final part, we have what we have left. We have left the, this time it is 40 mm, this time it is 28 mm, this one is 20 mm, and the last one is 12 mm. So this was the step turning process. You can see in the we have reduced the dia of from 40 mm to different steps of 28, 20 and 12 mm up to different lengths. Rest commands the same. F0.5, this was the feed weight. M08, this was for coolant on. We have used in the previous slide. Now coming to the end of the program, as discussed earlier, there are three parts of program. First part was the initialization, which we have set. Then the middle part, in which we have written all the code including G94. Now the end of the program. At the end of the program, the first one is G00. G00 gives the rapid linear into position to the tool. Means it moves the tool away from the workpiece to a specified position rapidly. Z10, it is similar. The tool will move 10 mm away from the workpiece in the positive Z direction. Means it again moving the tool away from the workpiece. And M09 is used for turning the coolant off. In the previous slide, we have used M08, in which we have turned the coolant on. Now in M09, we have turned the coolant off. G28, if by chance if you have not used G00, and then G28 reference point returns the tool first to G00 position. This is often known as intermediate position to which tool is returned. Then after G00, it will go back to the home position. Here reference points U, W, these are along about X and Z axis. I have selected both 00, so the tool will now return to X0 and Y0. At the end there is M30. M30 is used for the completion of the control program. It is always used at the end of the program. Now here our program is complete at M30. So far your coding is complete, your program is complete. Now we have to run the simulation for checking if any error is there, we can notify. Uh, there is a play button. From here you can run the simulation. So if there is any error, it will be notified. As discussed earlier, before working, we will run the simulation for checking the error. Here is the pause and stop button. If you want to pause or stop the program, you can use these buttons. And this bookmark icon, this is used if you have any confusion regarding any code, then click this icon. The detail for every code will be available to you for checking of any code or any other information regarding the code. Up till now your work is complete, your code is complete, simulation has been done. So now we have to save the project. Again, click the topmost icon in the right side. By clicking this icon, this window will appear. Here you will click the save project. By clicking this option, you will save the current all progress. Remember that don't use space in between the alphabets. Always use underscore sign, because the space sign will not be read by the software. So use underscore sign in between the alphabets if you have to use them. Also, in the next slide, there is complete video for the program written along with running simulation. Each step is described live one by one for better understanding. So if you have any confusion so far, please see the video in the next slide recorded in Urdu. Video will give you the detail of every step with running simulation. And thank you.
स्टेप टर्निंग ऑपरेशन स्टेप वीडियोस बेसिकली आप फाइल मैनेजर पे क्लिक करेंगे, सेम एज इट इज़ आप न्यू प्रोजेक्ट लेंगे और उसके बाद जो सेकंड ऑप्शन है आप वर्क पीस के पैरामीटर्स पे जाके इसको एडजस्ट करेंगे। जैसा कि हम हर दफ़ा अपने वर्क पीस का डायमीटर 40 mm रख रहे हैं, तो सेम 40 mm का डायमीटर आपने रखना है और क्लैंप लेंथ जो है वो 20 mm का आपने 3 जाचक में क्लैंप इसको रखना है। बेसिकली जो हमारा ये जो 3 जाचक है इसने हमारे वर्क पीस को जो है वो क्लेम किया हुआ है और ये हमारा टूल है। इसी तरह अब हम टूल के पैरामीटर्स पे आ रहे हैं। ये एक टूल का लॉक्स में जब हम जाके इसको देखेंगे तो इस बार क्योंकि हमने स्टेप टर्निंग करनी है तो स्टेप टर्निंग के लिए हमें कंटूर टर्निंग का टूल चाहिए, तो हम 18 नंबर टूल को ड्रैग करके लाएंगे और उसको 1 पे प्लेस करेंगे और ये स्टेप टर्निंग के लिए यूज़ होता है। इसमें हम फर्दर कोई चेंज नहीं करेंगे और हम इसी तरह कोड एडिटर की विंडो को ओपन कर देंगे। कोड एडिटर की विंडो में जैसे कि आपको पता है कि इसके मैनुअल एंट्री भी हो सकती है, लैपटॉप से भी हो सकती है, तो जस्ट हम कॉपी पेस्ट करेंगे अपने प्रोग्राम को और इसको आगे फर्दर देखेंगे कि ये प्रोग्राम की जो सिमुलेशन है क्या वो 100% एक्यूरेट है या नहीं है। आगे मैं आपको डिफरेंट इसके जो है वो कैमरा की लोकेशन दिखाऊंगा। कैमरा नंबर 1 है, जैसे कि ये आपका टूल है, ये आपका वर्क पीस है। टूल और वर्क पीस की कम्बिनेशन है। अब मैं इसके सिमुलेशन को रन करूँगा और ये हमारा तीजा चक जो है वो इसकी वर्किंग स्टार्ट हो चुकी है, ये कूलेंट ऑन हो चुका है और ये जो चिप्स हैं जो आहिस्ता आहिस्ता इसकी रिमूव हो रही हैं, ये बेसिकली हमारा जो वर्क पीस का मटेरियल जो है वो रिमूव हो रहा है। ये कैमरा नंबर 1 से आपको इसकी एक लुक नज़र आ रही है। इसमें मैंने इसके जो है वो टूल पाथ और इसके जो एक्सेस का जो है उसको ऑन किया हुआ है ताकि आपको ये जो ग्रीन कलर शो हो रहा है बेसिकली ये टूल पाथ को फॉलो करता है। तो स्टेप टर्निंग बेसिकली वेरियस डायमीटर्स जो होते हैं वो वर्कपीस को उसकी उसके लिए ये पूरा एक्सपेरिमेंट है। तो अब आपके सामने है कि जो है हमारा टूल जो है वो वर्कपीस के डिफरेंट डायमीटर पर उसको कट कर रहा है। इसमें आपको नज़र आ रहा है कि जो हमारा टूल है वो वर्कपीस के लेंथ के पैरेलल में जो है वो कटिंग कर रहा है। ये उसकी चिप्स जो हैं वो कटती हुई नज़र आ रही हैं आपको। और 3 चक जो है हमारे वर्क पीस को बेसिकली रिवॉल्व कर रहा है और उसकी स्पीड है 500 RPM और इसमें हमारी जो फीड रेट है वो जो है 0.5 है। और बेसिकली ये आपको टूल पाथ नज़र आ रहा है कि किस तरीके से उसको काट रहा है। अभी ये जो है वो X16 तक इसने इसको काट चुका है। बेसिकली डेप्थ ऑफ कट ये 4 mm की दे रहा है हर साइकिल में। तो अब X12 आके इसने ये जो है इसका प्रोग्राम अब क्लोज हो जाएगा और M30 पे बिल्कुल प्रोग्राम जो है वो बंद हो चुका है। ये हमारा फाइनल जो है आउटपुट है बेसिकली, जिसके लिए हमने ये पूरा प्रोग्राम रन किया। तो एट द एंड जो है हमारा जो है वर्क पीस एक्यूरेट जो आउटपुट हमें रिक्वायर्ड थी वो बन चुकी है। तो ये हमारा वर्क पीस है फाइनल और ये हमारा टूल है और डिफरेंट कैमरा की लोकेशंस आप देख सकते हैं। बहुत ही रियलिटी के करीब जो है ये एक सॉफ्टवेयर है।